Okay, this time, by the way, this is screencast number 2 for the Forces Virtual Lab. We're on the refrigerator, so let's look at the refrigerator. The refrigerator is going to be 200 kilograms. So let's put that up here. We're going to keep everything checked, and we're going to go back to our sheet, and let's put in our mass of 200 kilograms for this entire row. 200 kilograms. All right. We're going to do the same thing. No friction, medium friction, and lots of friction. Okay, so right now, set it to no friction at all. Apply a force of 500 newtons. Let's see what happens. Our sum of forces, or the net force, is going to be 500. But we're not getting a whole lot of acceleration, maybe about 2 or 3. Okay. Net force, 500 newtons. 500 divided by 200 is 2.5 meters per second squared. Okay, which is about what the accelerometer on the simulation read. So let's go to medium friction this time and see what happens. Okay. Alright, we're going to apply a force of 500, and this refrigerator is so heavy that the friction between it and the ground counteracts our applied force. So we aren't going anywhere. There's no acceleration because the net force is 0, because friction is completely counteracting our applied force. So our applied force was 500, but the net force is 0 because of the tremendous amount of friction that we had. So if we have 0 net force, we're also going to have 0 acceleration, so 0 meters per second squared. And y'all can probably already figure out that if it's set to medium friction and it's not going to move, well, when I set it to lots of friction, it's probably not going to move either. So let's look. And crank it all the way up to 500, and we have so much friction and such a heavy load that we're not going to move it at all. Okay, so again, our applied force is 500, but the net force is 0 because of the tremendous amount of friction that we've got. Okay, acceleration is going to be 0 meters per second squared. All right, so now we're going to look at these questions. The first one says, what happened to the amount of acceleration as the mass increased? And it says, look at the trends down each column. Okay. Okay, so we're going to look down the column, the trend down the column, looking at what happened to acceleration as mass increased. So as I go down the column, mass goes from 50 to 100 to 200, so it's doubling each time. What does the acceleration do as a result? Well, it was 10, now it's 5, now it's 2.5. So from here to here, half. From here to here, half again. All right, so please write a complete sentence. What happened to the amount of acceleration as mass increased? And I would start it like this. As mass increased, the acceleration decreased. Okay, so I made sure that I wrote this in a complete sentence because that's what I expect you guys to do too, which means it begins with a capital letter and it ends with a period and it's got a subject and a verb. As mass increased, the acceleration decreased. Okay, the next one says, what happened to the net force applied as friction increased? And it says, look at your net force data across each row. So this time, I might come up here and look across this way. All right. I start out with no friction. My applied force is 500 and my net force is 500 because there's nothing counteracting my applied force. But then we add some friction which partially counteracts my applied force, and the net force goes down. The net force goes down as the amount of friction goes up. So, what happened to the net force applied as friction increased? And you can write it in a complete sentence. As friction increases, the net force decreases. All right, so as friction increases, the net force decreases. The last question is, it says, name 3 things that could be done to maximize the acceleration possible. Well, if you do a little bit of thinking, the first thing that you can do would be to decrease the mass, because we noticed that lighter things accelerate more. Okay, so our least massive object is going to accelerate the most, so decrease mass would be 1. We could do as much as we can to decrease friction. And the third thing is we're going to want to increase our applied force, the amount of force that we're pushing on it with. Increase applied force. So, all of those things would work to increase our acceleration. All right. Remember, Newton's second law is the one that states that acceleration depends on the net force and the mass. And acceleration is going to increase if we increase net force, but acceleration is going to decrease if the mass increases.